All right, so first and foremost, I would like to apologize for my voice. Obviously, I've been missing a few days in class because I've been under the weather. Hopefully, you can still understand me at the very least. We'll have a few of these problems from 2.5 and 2.6 worked out in video form, so you can go back and see how rewatch how I worked them out. So we're going to start chapter 2, section 5, working on example problems. And we're going to be dealing with equations of lines. So the first equation of a line, at least the first form that we're going to be dealing with, is the point slope form. And the formula for the point slope form, y minus y1 is equal to m times x minus x1. Hence the name. We use the point slope form when we want to ask for the equation of a line, and we're given the point, or at least a point on the line, and the slope, or at least enough information for us to find the slope. Keeping in mind, we have a slope formula, and we will be using that on some of these problems. Another form we're going to be dealing with is the slope intercept form. And the slope intercept form is y equals mx plus b. This is where the number in front of x is our slope. The number being added or subtracted to the entire equation is our slope intercept, our y-intercept, should I say. We know we can get in the slope intercept form by solving for y, and we should have one singular positive y is equal to some number plus or minus in front of x, added or subtracting a number to that slope. All right, so our first example, and we're really going to be asking, at least for this type of problem, we're going to be asking ourselves, what do we have, what can we get, and what are they asking for? So our first example, they give us a point on the line. Let's say the point is -4, 1. And they also tell us that the slope of this line is -3. There's actually a couple ways we can, and we're asked for the equation of the line. There's a couple ways we can use. We can either use the point slope form. Hint, we give it a point, give it a slope. So we use the point slope formula. Y minus y1. Remember, here I label my points as x and y. We only have one x and one y, so this is x1 and y1. So we use our formula, y minus y1, or in this case, y minus 1, is equal to our slope, -3 times x minus x1, which would be -4. Subtract a negative, just like that. So we're starting with y minus 1 is equal to -3 times x plus 4. First thing I would do, go ahead and distribute that -3. So this is going to give me y minus 1 is equal to -3x minus 12. Remove the whole quantity to get y by itself, so we can just add 1 to both sides of the equation. So the equation of this line will be y is equal to -3x minus 11, because -12 plus 1 gives me a -11. Right? So this will be the equation of the line in slope intercept form. For my slope, -3, just like it was given to us in this problem. The y-intercept we had to find by using the point slope form, which would be -11. But remember, we could also use the slope intercept form to solve this. If we would take that route, slope intercept form, from the slope intercept form, y equals mx plus b. So here, my y would be 1, given to me by my point. My slope is also given to me, -3. The x value, and this one of pair is -4. So we can set it up saying that y, or 1, is equal to my slope, -3 times the x, -4 plus b, which is really what we're looking for the slope intercept form. So this would be 1 is equal to -3 times -4, gives me a positive 12, plus b. We're trying to figure out what b is, so we're going to have to isolate it by subtracting 12 from both sides. So here, b, which is by itself, just change the sign, then it's on an equal sign, is equal to 1 minus 12, or -11. So for slope-intercept form, we'll have y is equal to my slope given to me in the problem, negative 3x minus 11, my y-intercept that I just found. Notice that either route that we take, we still end up with the exact same equation with slope-intercept form. Another scenario that they can give us this time, they ask to find the equation of the line in standard form. But in this scenario, they're giving us 2 points, and we're asked to find this. We're asked to find the equation. If they give us 2 points, we want to find the slope first. All right. And we're asked to find this answer. Well, first off, the points they give us: negative 4, 3, 5, and negative 1 is my second point. And we all want the answer in standard form. In standard form, ax plus by is equal to c. So first, we can use our slope formula. Remember the slope formula? That lowercase m is representative of our slope. I will label my points x, y, first x, first y, second x, second y. Slope formula, y2 minus y1, or in this case, negative 1 minus 3, over x2 minus x1, or in this case, 5 minus negative. So this gives me a slope of negative 4 for my numerator, positive 9 for my denominator, or the fraction, negative 4/9 is the slope. All right. So now that we have our slope, we can use either the point slope form, picking one of the 2 points given to us, keep in mind that these 2 points are on the line that we're looking for, or we can use slope-intercept form, y equals mx plus b, still choosing either one of these 2 points, and along with the slope, negative 4/9 in both. So I'm going to do the point slope form first. So we'll have y minus y1, or y minus 3 in this case, is equal to my slope, negative 4/9 times x minus x1, or in this case, x minus a negative 4. So we subtract a negative, just like that. All right, distributing that 4/9, this will give me y minus 3 is equal to negative 4/9 times x, will give me negative 4/9 x. Negative 4/9 times positive 4. Negative times positive give me a negative. 4/9 times 4 will give me 16/9. Right. Now remember, we want this answer in standard form, so we're going to have to get rid of the fractions. So we also want to make sure that a is positive. So to handle this, first thing I have to do is get rid of all the fractions by multiplying by the denominator. In this case, we actually have the same denominator, 9. We want to multiply everything in the equation by 9. So now I have 9y minus 27 is equal to negative 4x minus 16. So I multiply everything by 9. Obviously here, if I multiply by 9, the denominators cancel, we get negative 4x and 16. And remember, if we do it for one thing in the equation, we must do it r. If we're going to multiply in the equation, we must multiply everything in the equation by the number that we chose, in this case 9. Now, put it in standard form, all we got to do is collect our like terms, but we can organize the problem. Ax plus by is equal to c. So I'm going to need to move this negative 4x to the other side, because we want my a to be positive. We've already got rid of our fractions. And move that negative 27 to the other side with the constant 16. So just to be clear, we're going to add 27, as well as adding 4x. So we will end up with 4x, positive 4x, plus 9y is equal to 27 cancel, negative 16 plus 27. That will give me a positive 11. So this is the equation of the line that we're looking for in standard form. Now we're using the slope-intercept form, or the method using the slope-intercept, or y equals mx plus b. We can still use the same point, -4, 3, along with our slope, positive, excuse me, -4/9. Plug everything in its appropriate place. So we will have 3y using x1, y1 is equal to my slope, -4/9 times x, -4, plus b. And we can use this to solve for b. Keep in mind that we want our answer in standard form. So this will give me 3 is equal to, negative times a negative will give me a positive. Turn this -4 into a fraction by putting it over 1. -4, positive. 16 for my numerator, 9, plus b. We need to get b by itself. So we're going to subtract 16/9 from both sides. So here, positive 16/9, negative 16/9 is going to cancel. 3 minus 16/9. Remember, we can rewrite 3 as a fraction with the denominator of 9. Remember, 3 as a fraction is 3 over 1. So we have to multiply everything by 9. So this is really 27/9, or 3 minus 16/9. 27 minus 16 will give me 11/9 with the b that we're looking for. Right? So slope-intercept form, this will be y is equal to -4/9 x plus 11/9. And then we can just use some manipulation of our algebra to write it in standard form. Bringing the x to the other side, making it positive, multiplying everything by 9. And we'll end up with the same answer in standard form. 4x plus 9y is equal to 11. I mean, this is just general manipulation of equations. If we have any questions, just feel free to email me or come to me, and I'll be glad to show you how to go from here to here. It's the exact same process, though. All right. Another scenario. 2.5 we need to be aware of. Here we're asked to find the slope and the y-intercept, given the equation in a different form. So here, let's find the slope and the y-intercept. And we're given the equation 3x minus 4y is equal to 12. So we're asked to find the slope and the y-intercept for an equation that's given to us in standard form. So if it were me, the easiest way to do that is to put in the slope-intercept form. Y equals mx plus b, which means we need to solve for y, or get y by itself on the left-hand side of the equation. The first thing we're going to do is subtract 3x from both sides. It's going to be a -4y is equal to -3x plus 12. Divide, and then to get the y by itself, divide everything by -4. So we end up with y is equal to positive 3/4 x minus 3. Now that we have this in slope-intercept form, the number in front of x is my slope. The number by itself being added or subtracted to the slope is my y-intercept. So in this case, to answer my questions, my slope, positive 3/4, my y-intercept, -3. Right, so we're asked to find the slope, the y-intercept given equation, just solve for y. Making sure to put the number attached to x in front, number by itself last. All right. Another type of problem you're going to see in this section. Here, we're given 2 points, and we're asked to find the equation of the line. The points given, -2, 4, 2, 2. When we give us 2 points, general rule, they'll give you 2 points on the line, go ahead and solve for the slope. So my slope, the formula for the slope, y2 minus y1 over x2 minus x1. I always suggest labeling those points first. First x, first y, second x, second y. Start doing the work over there. So my slope would be y2, or 2 minus y1, 4 over x2, 2 minus x1. So we'll be subtracting a -2. So it's going to be subtracting a negative, or essentially adding. We know 4 minus 2. It's going to give, 2 minus 4. So it'll give me a numerator of -2. On the bottom, 2 plus 2, 4. This fraction can be reduced down to -1/2. So this is my slope. We have 2 points. So we have 2 methods we could take. We can either take the point slope method. So we have a point and slope. So we use point slope formula. Or the slope intercept. Y equals mx plus b. I'll do both. So here, point slope method, we can have y minus y1 or 4 is equal to my slope, -1/2 times x minus x1, which will be positive 2. Or obviously subtracting a -2, we subtract negative just like that. So we can simplify this. This will give me y minus 4 is equal to, distribute that -1/2. That's going to be a -1/2 x. -1/2 times 2 is going to give me a -1. Last step, get the y by itself by adding 4 to both sides. So the equation that we're looking for will be y add 4 to both sides is equal to -1/2 x. -1 plus 4 gives you a +3. This is the equation of the line that's sloping itself here. We also could do it the slope intercept way, or we're just searching for b first. Or we're going to have y equals mx plus b is the equation we're going to use. Or 4, which is my y, is equal to my slope m, or it's probably found to be -1/2 times x, which was -2. It's going to be 4 is equal to -1/2 times -2. It's going to give me a +1 plus b. And to get the b by itself, let's subtract 1 from both sides. So b equals +3 because 4 minus 1 gives me 3. So now we have our slope, -1/2, my y-intercept 3. So we get the same equation. Y is equal to -1/2 x plus 3. Does not matter to me which method you take, the point slope form or slope intercept form, because we're going to end up with the same equation, provided we do it correctly. All right, still in 2.5. This time we're going to be asked to find the equation from a graph. Let me put a quick sketch of our graph here. So in this example, we were asked to find the equation from the graph. And we're given this graph. So the graph has a y-intercept, or the first point, 0, 5. So it has a y-intercept of 0, 5. It also has an x-intercept of -2, 0. All right, now this is the line. If you have 2 points, that's enough to define a line. But we want to get the equation of the graph. There's a couple ways that you can look at this. Me personally, the easiest way, we have our y-intercept, we have the graph. We want to remember that our slope is how we get from one point to another. So we can go up 1, 2, 3, 4, 5, over 1, 2. I'll count it, and my slope will be +5/2. Keep in mind, if going up is positive, to the right is positive. But even if we went the other way, from 0, 5 to -2, 0. Going down 1, 2, 3, 4, 5, -5 over left 1, 2, -2 still gives me +5/2 because a negative divided by a negative is a positive. Or we can use the slope formula to get the same answer. Here, I'm going to have y2 minus y1. Me personally, it's x1, y1, x2, y2. So we have y2 minus y1 or 5 minus 0 over x2 minus x1, 0 minus a -2. Either way, still end up with +5/2 as my slope. Now, if you understand what y-intercept means, we can just look at the graph and see the y-intercept, +5. It shows it right here where it intersects the y-axis. The x-intercept, or y-intercept technically is 5, but just for the sake of argument, That's going to give me a B, which is my y-intercept of 5. My x-intercept given to me in the graph, and that is the ordered pair, -2, 0. So the equation of this line, we have y is equal to my slope, 5/2 x, plus b, or plus 5. This is the answer. In slope-intercept form, if we want it in standard form, we can manipulate this equation pretty easily. Also want to remember a couple things. One, that a vertical line has the equation x equals a, or x equals some number. Or a horizontal line has the equation y is equal to b, or y equals some number. All right. Keeping in mind that every ordered pair, x is first, y is second. So x equals a, y equals b. A couple other relationships. Parallel lines have the same slope. Remember, parallel lines are basically lines that are never intersect. Or perpendicular lines have opposite reciprocal slopes. Remember, perpendicular lines are two lines that intersect and form 90 degrees. All right, so as we put the top of that, let's say we have a slope. They're given a line and we're told that the slope is equal to -3/4. If we're looking for a line parallel to it, then the slope for the line parallel to it is also -3/4 because parallel lines have the same slope. If we're looking for the slope of a line that's perpendicular to it, then it would be a positive 4/3 for the slope. Or opposite reciprocals. If it's negative, make it positive, flip the fraction. If it's positive, make it negative, flip the fraction. So -3/4 becomes positive 4/3 for perpendicular lines. Good example of this. Let's say we're given a line who has a point that goes through the order pair 2, -4. And we're going to look for both a line parallel and perpendicular to the line that has the equation 3x minus 2y is equal to 5. All right, so we know two things about the line given. One is the equation of it in standard form, obviously. We go through this point. We're going to find a line parallel to it, which means it has the same slope, and a line perpendicular to it. The equations of these lines. Remember, keeping in mind the perpendicular lines have opposite reciprocal slopes. So first thing we need to do is find the slope of the line given. If it's given to us in standard form, you can manipulate it, solving for y to put in the slope-intercept form, and the number in front of x is the slope. First thing I would do, move 3x to the other side by subtracting 3x. So it's going to give me a -2y. It's equal to -3x plus 5. And then again, to get the y by itself, we must divide everything by -2. So this will give me y is equal to positive 3/2 x, because a negative divided by a negative is a positive. Minus positive divided by a negative gives me a negative 5/2. All right. The biggest thing is that we can get to the slope of the line that we're given positive 3/2 because that's the number in front of x. All right. So as far as the line parallel to it, we start working on that one first. We can use the point slope formula because remember, they told us that it goes through this point and has a slope of 3/2. So we can use that point and this slope to get a line parallel to. So point slope formula, y minus y1, in this case, -4. So y minus -4 or y plus 4 is equal to my slope, 3/2 times x minus x1, or in this case, my x coordinate is 2. All right. So we can start solving this. This is going to give me y plus 4 is equal to, distribute that 3/2. 3/2 times x gives me 3/2 x. And 3/2 times -2 is going to give me a -3. We can subtract 4 from both sides and get the y by itself. And the equation of the line parallel to this line and goes through this point would be y is equal to 3/2 x minus 7. Right. Now another way of writing this, we want to write this in standard form, just manipulating the equation. Oh, I forgot to write it. I see 3/2 x, we didn't write it. Or in standard form, we're going to move the 3/2 x, or excuse me, move the y over with this 3/2 x, keeping it positive. With the 3/2 x, and move the 7 over. And multiply everything by 2 to get rid of that fraction. So in standard form, this will be 3x minus 2y is equal to 14. All right, so technically, either way, sloping this up form or in standard form, these are both still the equations of the line. All right, and also note, this equation is not the same as this one, but they do have the same slopes. Now we can work on the one perpendicular to it. Keeping in mind, if it's a perpendicular line, the slope is a negative reciprocal. So here, we're going line to go from the point to -4. And it's perpendicular to the line that has a slope that we found of 3/2. So this is the slope that we're starting with, 3/2. If it's perpendicular, this means that the slope that we're dealing with is a negative 2/3. Opposite sign, went from positive to negative, flip the fraction. That's the relationship the perpendicular line have with their slope. So now that we have our new slope, we already have the point 2, -4. We can find our solve for the equation of a line that's perpendicular to it. So this will be x1, y1, just in case we haven't picked that up yet. So we will have y minus y1, or in this case, y plus 4, because if we subtract a negative, y minus -4 is y plus 4, is equal to our slope, -2/3, times x minus x1, or in this case, x minus 2. All right, so first thing we're going to do, distribute a -2/3. That's going to give me y plus 4 is equal to -2/3 x. Negative times negative gives me a positive. 2/3 times 2 would actually give me a positive, excuse me, -2/3 times -2 would give me a positive 4/3. All right. Now we just need to get the y by itself by subtracting 4 from both sides. So we have y is equal to -2/3 x. And it's really 4/3 minus 4. We're just going to put this over here just for the scratch work. So 4/3 minus 4 as a fraction, that's 4/1. Me personally, just to do a quick technique that I use whenever I'm adding or subtracting fractions to flying x. So this would be 4 times 1 or 4 minus 3 times 4 or 12 over 3 times 1, which is 3. So this is actually going to give me a -8/3. So we're going to subtract 8/3 from it. And this is actually the equation of this line and slope in step 4. Now, if we want to write it in standard form, and I'll go through the steps this time for writing in standard form. Here, to put it in standard form, because my x is negative, I'm moving over with my y by adding 2/3 to both sides. So I will have 2/3 x plus y is equal to negative 8/3. We get rid of the fractions, we're gonna multiply everything by 3. So this will give me 2x plus 3y is equal to negative 8. And this will be our answer. Standard form. Different type of problem, same scenario, or same type of problem. This time, they're gonna give us the equation line. Let's say the equation given, 3x minus 2y is equal to 5. And it goes through the point 2, negative 4. You know what? I actually think we covered enough. I don't like this last example, so we're gonna eliminate this. All right, but these are gonna be the examples for 2.5. These are the type of problems that you're gonna need to know how to solve to work the homework for 2.5. I'm also gonna go ahead and go to 2.6, which is really just a lot of information on the types of graphs. Intervals of increase and decrease for said graphs, as well as piecewise defined functions. This one shouldn't take long to go on. So once again, 2.6. Talking about graphs. All this information about graphs, going into problems. Right. So we went over a few graphs already. First one we're going to review here is the graph of a line, or the function f of x is equal to x. So remember, we need to know that this is the graph of a line. All right, the domain is the entire real number system. The range is also the entire real number system. Now this graph increases from negative infinity to infinity. And this graph is also a continuous function, or it is continuous from negative infinity to infinity. Another graph that we need to know is the graph of a parabola, or that graph is like a U. That's the graph of the function f of x is equal to x squared. So like I said, that is a parabola where the domain, the entire real number system, the range, open parentheses, 0, comma, infinity, are defined for every value greater than 0, excluding, or excuse me, that should actually be including 0 itself. So let's say open bracket 0 to infinity. Sorry about that. And this function decreases from the interval negative infinity to 0, where it's going down the page from left to right, all the way from negative infinity to 0. Then it starts in turns and goes up the page. So it's increasing from 0 to infinity. And this function is also continuous from negative infinity to infinity. In continuity, to say when a function is continuous, it just means there's no holes, no breaks, no jumps in the graph. Next graph that we need to know, the next graph that we had reviewed is the graph of interest, is the function f of x is equal to x cubed. That's the graph that looks like a snake. Other people, for some reason, said John Travolta. So that's Trauvol. No, I don't. Is that John Travolta one, where it looks like he's doing a little dance and thing. I guess if you watch the movie, that makes sense to you. Either way, the domain, the entire real number system, the range is also the entire real number system. This function increases the entire domain from negative infinity to infinity. It's also a continuous function from negative infinity to infinity. Hope that would make sense. All right. That graph is the radical function, or the function f of x is equal to the square root of x. So we call that one a shooting star. Or you can think of it like a right turn. Here the domain for this function, open bracket 0 to infinity. When you can take the square root of any positive value and 0 itself and get a real number. Well, the range for this function is also open bracket 0 to infinity. This function increases the entire domain, or open parentheses 0 to infinity. Remember, for animals of increase and decrease, we always put it in parentheses. This function is also continuous on this entire domain. So from 0 to infinity. Another graph would be the cube function graph, or f of x is equal to the cube root of x. Some people refer to this one as a swimmer. The domain is the entire real number system. The range is also the entire real number system. This function increases from negative infinity to infinity. It's also continuous. From negative infinity to infinity. Last graph we need to know, absolute value graph. Looks like a V. That's where the function f of x is equal to the absolute value of x. The domain of this graph is the entire real number system. The range for this graph, open bracket 0 to infinity. This graph decreases from negative infinity to 0, increases 0 to infinity. It's continuous. The entire real number system from negative infinity to infinity. So this is information that we need to know about these graphs. 2.6. We also want to go with the piecewise defined function, how to graph them, as well as how to analyze them, or evaluate a piecewise defined function. So once again, piecewise graphs. So we're doing with piecewise graphs. Let's say we're given the function, or the piecewise defined function f of x is equal to 2x plus 4 if x is strictly less than 1 and is equal to 4 minus x. If x is greater than or equal to 1. So that's two linear functions that obviously break apart, or it takes over one piece of the function and goes for another, or goes from one piece, 2x plus 4, to the other piece, 4 minus x, at 1. Yep. So if you're me and I'm graphing this, I'm just going to graph this by hand. Keep in mind, you do have a graphing calculator. Take advantage of the fact that you have a graphing calculator. All right, so we're graphing 2x plus 4. The first part, it has a y-intercept of positive 4. So go up 1, 2, 3, 4. This is going to be a point on my line. And we also have a slope of 2, which means there's really 2 over 1, or from this point to the next. We go up 1, 2, to the right 1. This is another point on my line. Note that I'm putting 0 here, or excuse me, an open circle here at 1, because this is only this function is strictly less than 1. Either way, once we have 2 points, that's enough for us to define a line. And everything less than 1 is going to be to the left. Is going to be to the left of 1 on the x-axis. And for 4 minus x, we can rewrite this as negative x plus 4. Why one might want to do this, because now we can see the positive 4 my y-intercept. Keep in mind that f of x is 5. So my y-intercept or slope negative 1, or negative 1 over 1. So I can start at positive 4. And now to go from one point on my line to the next, I go down 1 and to the right 1. So this is going to be one of my line. I'm going to have a closed circle here because it's going to be this graph greater than or equal to 1, or equal to means it includes this point. Either way, from here I can go down 1 over 1. That's going to be another point on my line. Once I have 2 points, that's another defined line. This is going to be the graph of my piecewise defined function. So it's 2x plus 4, or our line at a positive slope all the way up to 1. Open circle at 1, because when x equals 1, is a part of this part of my piecewise defined function, or 4 minus x. 4 minus x can be written as y is equal to negative x plus 4, just changing the order in which these are presented. So there's a slope intercept form, where my slope 1, or negative 1 over 1, or y-intercept positive 4. So this is the graph of that piecewise defined function. Let's go to another one. Let's say we're given the piecewise defined function f of x is equal to negative x minus 2 if x is less than or equal to 0, and x equals x squared minus 2 if x is greater than 0. Remember, a good way to check these is to simply plug these functions into your graphing calculator and make sure that it looks the same. We have those same graphs. All right. If not, or excuse me, that's a good way to check it. But we want to remember that the piecewise defined function is only a part of each of these 2 graphs. So you got to remember this part of my piecewise defined function, parameters tell me where to cut it off and what part of my graph to keep. All right, so we're graphing this one. Oh, really quick. In terms of domain and range for this piecewise defined function, the domain, the entire real number system, there is no x value that won't land somewhere on this graph. The range is also the entire real number system. There is no y value that doesn't intersect this graph somewhere. Now for this particular graph, this piecewise defined function, we have a linear function on graph of a line, y-intercept negative 2, slope negative 1. And it's going to change right on the y-axis where x is equal to 0. Closed circle for the first part, because that's equal to. The second part, which is a parabola, going through 0, negative 2. Our parabola shifted down 2 units. Remember, we could always use our graphing calculator to check. It also is going to have an open circle for this part of the graph on the y-axis. All right, so just a quick sketch for our graph. All right. So for the graph, first piecewise defined function, negative x minus 2, y-intercept of negative 2. So we go to negative 2. And technically, we should put an open circle here on negative 2 because it does not include 0. Now our slope is negative 1 over 1. So we either go down 1 and to the right 1, or we can invert it. Because remember that we're going down and to the right, that next point won't be on this graph because that's obviously greater than 0. Or we can go up 1 and to the left 1, up 1 to the left 1, and this gives us some more points on our line. Because if we go up and to the left, that's the same as down and to the right. Still on the same line though. But this would be the line for the first part of my piecewise defined function. And for the second part, x squared minus 2, we can use a graphic calculator. That's going to give me a parabola. It goes through the order pairs 0, -2. So that's going to go right where that open circle was. Going to have put a closed circle. I'm sorry, actually should have been a closed circle from the beginning because of the or equal to. But nonetheless, because this second part of my piecewise defined function is parabola, it's going to be that U-shaped graph for everything greater than 0. So these two graphs actually intersect. So there is no hole, there is no jump, there is no discontinuity. Whereas the first piecewise defined function, it will be discontinuous because we have to lift our pencil at this point to jump down here. So this would be the graph for the piecewise defined function. The domain will be the entire real number system, where the range will be open bracket 2 to infinity. These are the y values. Everything above 2 is a part of my range, including 2 itself because we got that closed circle on it. Last part for 2.6 is evaluating a piecewise defined function. This time we're given the function f of x, which is 2x plus 4, and 4 minus x. Matter of fact, that's going to be the first part, first piecewise defined function. This is where if x is strictly less than 1, and 4 minus x if x is greater than or equal to 1. So we're asked to analyze f of -1. X is -1 here, so that's my input. -1 is obviously less than 1. So we're going to look to the parameters of the problem and see which one gives us a true statement to tell us which part of the piecewise defined function we're going to use. So if x is -1, -1 is less than 1, then that's true. So we'll be using 2x plus 4 to analyze this part of my piecewise defined function. So I need to rewrite f of x. This is the part of the piecewise defined function that we're going to use, replacing every x with -1. So here, this will be 2 times -1 plus 4. We know 2 times -1 will be -2. -2 plus 4 will be +2. So f of -1, +2. We're asked to analyze f of 0. Just like before, my x is 0 here. 0 less than 1, that gives me a true statement. I'm going to use the first part of my piecewise defined function again. So I'm going to replace every x in f of x with 0 and then analyze. So this will be 2 times 0 or 0 plus 4. So f of 0 will be +4. And then we're asked to analyze f of 2 here. 2 is my input, or 2 is my x. 2 is less than 1, that's a false statement. 2 is greater than or equal to 1, that's a true statement. So this time we're going to use the second part of my piecewise defined function, or 4 minus x. So I'm going to replace every x in f of x with 2 this time. Or in this case, I'll have 4 minus 2. F of 2 will be 2 once again. So we're evaluating a piecewise defined function. These are going to be the questions they're going to have to ask f of some number. We're going to use that number and use the parameters of the piecewise defined function to find out which part of the piecewise defined function we're going to use. And then after that, it's just like any other function. Replace every x in f of x and analyze it, making sure that we're using the appropriate part based off the parameters. Another perfect example. This time we'll use that second piecewise defined function here, where f of x is equal to -x minus 2 when x is less than or equal to 0, and f of x is equal to x squared minus 2 if x is greater than 0. This time we're asked to analyze f of -1, f of 0, and f of 2. Hopefully this makes more sense, so I'll move a little quicker this time. F of -1 X is -1. Is -1 less than or equal to 0? That's true. So we're going to be using -x minus 2 for f of -1. So we're going to replace every x in f of x with -1. Everything else is going to stay the same. So what was -x minus 2 is now -1 minus 2. -1 is going to be +1. +1 minus 2 actually gives me -1. So f of -1 ends up being -1. F of 0. X is going to be 0 this time. That's my input. 0 is less than or equal to 0. True statement. So I'm going to use -x minus 2 again. It's going to be -x minus 2. -0 is 0. 0 minus 2, -2. So f of 0, -2. And for f of 2, I'm going to use those parameters. This time x is 2. 2 is less than or equal to 0. False statement. That's not true. 2 is greater than 0. That's a true statement. So this time I'm going to be using the second part of my piecewise defined function. So f of 2 is going to replace every x in f of x with 2 this time. So here we're going to have 2 squared minus 2. 2 squared 4. 4 minus 2 gives me 2. So f of 2 is actually 2 itself. This is going to cover the example problems for 2.5 and 2.6. I apologize for the quality of my voice. I apologize for missing class, but honestly, I'm just not getting to a point where I can talk again, and it's not, I'm not so under the weather that I can actually teach. Okay. Also, I noticed that I didn't receive any emails as far as homework problems. I have been out a lot. I hope you guys are keeping up with the work that I've been placing and keeping up with the lecture and the homework. And be coming. Hopefully, I'll be back 100% strength next week. So I'll see you guys next week, regular class time, and I'll give you make sure that I make myself available to answer any questions. Outside of that, there'll be luck studying, and I'll talk to you guys next week.